Hello, grade 6, 7, and 8s. Today we're going to try something a little bit different. It's almost like I'm asking you to do what we would have done in class if we were taking a note. So I have provided you with a blank copy of the note that looks something very similar to this, and I'm going to fill it in with you. I'm going to ask you to fill it along with me as you watch the video, and then there's some questions for you to answer, and I'll give you a couple of days to get those done, and then we'll talk about them a little bit, maybe in some small groups, or we'll see how the answers go. When you look at your page, you will first notice that I have added the definition of mass that we've talked about before, where mass is the amount of matter in an object. I have also added the definition of volume, which is how much space something takes up. And we talked about both of those at the beginning of this unit. So if you take a look at those are good starting places for us to talk about the new concept we have called density. So when people usually talk about fluids, you guys have talked about things like you'd say this fluid is really light, and you might be talking about something like water or oil. And then you might say certain things look really heavy as you talk about fluids like molasses, for example, like the one we had looked at in the what a mess thing that you guys had handed in. But now we want to think about what these terms really mean. So to truly understand these terms, we have to start with the exact same, and we'd say volume of a substance. So you definitely couldn't say, well, these 50 cannonballs weigh more than this tiny little glass of water. So you have to make sure that everything's equal. So one drop of water would surely not be heavier than a liter of oil. So you wouldn't expect that one little droplet of water would be heavier than a full liter of something else, but you want things to be the same. So then we'd look at it and we'd say, but 1 liter of oil is actually lighter than a liter of water. You could take this as saying that oil has less, and the words we had up here was mass. So they have the same amount of volume, they're both a liter, but one of them is lighter than the other. And to quickly illustrate that, I've got 2 glasses here. One of these is filled with water, which is this one here, and then this one filled with oil. So if I take the one and I pour this one into the other, you will notice that now they both take up the same space, but one of them is on top of the other, which means that the oil that I just poured in has to be lighter than the water. So really you could take that as saying it has less mass, but another way to look at this is when we compare the masses of the same volume of different substances, what we are really comparing is, our new term is comparing their densities. Okay, we're comparing something called density. That's our new concept here. So really, oil floats on water because it is less, the new term we'd use is less dense than water. So if we were to use particle theory and show how these blocks could look, if you were comparing the density of oil and water, we might say, well, oil has particles that are doing something kind of like this. Water has particles that look maybe something like this. And why can the oil float on the water? Because it has less particles in the same amount of space, therefore it's less dense. So what might lead look like? Oh, I'm not even going to start filling that in, because what we could really do is pretty much color in the large majority of this space. So water would sit on lead, but oil would sit on water because there's less particles in the exact same amount of space. Another way to look at this might be by saying something like density equals the mass of an object divided by the volume of the object. Or more simply, we could say density equals mass divided by volume. So really what we're saying is density is the mass of a substance per unit of volume of that same substance. The way we usually express that then is, you guys are used to seeing things like grams or milliliters or centimeters cubed, but because density is a measurement of mass and volume, we measure it as something like grams per milliliter, or grams per cubic centimeter, or kilograms per cubic meter. So then we can start doing interesting calculations. So somebody said something like a cube of water has a volume of 2 meters cubed and a mass of 2,000 kilograms. What is its density? Well, we take our formula and say density equals mass divided by volume. We know that it has a mass of 2,000 kilograms. We know that it has a volume of 2 cubic meters. We divide these and we could say that it has a density of 1,000 kilograms per meter cubed. We are not going to be doing a lot of these calculations today, but what we are going to have you starting to look at today is a table that looks something like this. Looking at this table, you can see lots of interesting things. So for example, they're giving us measurements in grams per centimeter cubed, or for some things like these gases at the beginning, it makes more sense to measure their weight in kilograms per cubic meter because they're so light. So you'll notice how light they are when you look at how small these measurements are. So obviously the lightest thing we have here is hydrogen. And if you look, these numbers get higher. So obviously gasoline is now a liquid. It has a higher density than that of hydrogen. We can go down the table and look at things like mercury, which is still a fluid. It has a density of 13.55. So anything that has a density lower than 13.55 would float on top of mercury. Then we can look at the density of solids too. And we have things like wood and balsa wood and birch wood, and we have ice and sugar and salt and lead and silver. And it's interesting to note some things, like for example, if we look down here, lead has a density of 11.34, but lead would actually float in liquid mercury because mercury has a density of 13.55. So you have a bunch of questions that you are going to be asked to answer that look like this. So when you are finished, you will hand in the completed note that I just did with you, and you will answer the questions based on these terms right here. So this is the chart you need. You can answer it in point form if you like for the large majority of them, except for probably question 10. Other than that, we'll talk to you guys soon and take a look at all these answers together. Bye.